dear students. Today we are starting a new chapter, sound. So, students, especially the basic knowledge about the sound you have learned in class 9, in 7A portion already that has given in your book that what is reflection of sound and characteristics of sound wave. So that I will explain first, and I know that you have the idea, you have the knowledge regarding that. So let's start it. So sound, students, sound is you all know that a form of energy, a form of energy that we'll use to hear, that we can hear, okay, that we can hear. And so it will travel in the form of waves, okay. So sound, what is a sound? Sound is a form of energy that we can hear, and it will travel in the form of waves, okay. So how if the wave will create, because sound needs a medium, okay. When vibration of the medium happens, when vibration, by the vibration of medium, because student, without medium sound can't travel, okay. Sound can't travel in vacuum, so sound need a medium. So if so medium means there is the particles, okay. So particles are present in that medium, they will vibrate and produce the sound wave, okay. So students, you know that. And so there is the frequency of audible range, you know, 20 hertz to 20,000 hertz, okay, which is also known as sonic sound, okay. You can say that this is the audible range, that is the audible range we can hear if the frequency of sound wave is between these two. And if below 20 hertz, that is called infrasonic, and above 20,000 is called ultrasonic, okay, which we can't hear this. And you know that vibration produced by the bat to uh, move here and there, okay, when they will fly. Bats are blind, so they generally produce ultrasonic sound, and generally we can't hear it because its vibration is 20,000, means frequency is high, so it's more than audible range, okay. So students, I hope that basic thing you know, you understand. Now come to learn about the what is amplitude. What is amplitude? You know that the extreme when a complete vibration happens, the extreme point between two vibration is called the amplitude, which is designated as a, suppose if there is a pendulum, which is suppose if you pluck it, okay, then it move to extreme, then you can say that is its amplitude, okay. That from mean position to the extreme side, that is called the amplitude, one extreme, okay. So students, that term I will explain, okay, that is called amplitude, and designate a like time period. Students, similarly time period you all know, t, time period is the time taken to complete one vibration, time taken to complete one vibration. So time taken to complete one vibration is called time period. Similarly students, now move to the frequency. Frequency, you know, frequency is the number of vibration in 1 second, number of vibration in 1 second. So the relation between time period frequency is equal to 1 by time period, okay, that you know, you learn in class 9. And lambda is called wavelength. Wavelength means distance travel, distance traveled in one time period, in one time period, okay. Means suppose this pendulum come that extreme, then the middle each position is called mean position, then come to that extreme, so come here, then complete, then come to the mean position, that one complete vibration. You can say, suppose if the vibration transverse wave is like this. Now I am coming to the nature of wave, longitudinal and transverse, okay. So that I am coming, suppose that is a transverse wave. So that one extreme, that is amplitude, that is amplitude. So one complete wave up to this, okay, that is called one lambda. Okay, means the in one time one complete that is one vibration. So time taken to complete one vibration is called t. Okay, so that is the distance travels in one vibration. Okay, that is called in one vibration means one time period, you can say, that is called the wavelength. So I hope you understand about the wavelength also. Now students, the type of wave for produced means sound will move, that is called longitudinal or longitudinal, and generally it is called mechanical wave. You know, mechanical wave is two type, longitudinal and transverse. So sound is travel in both form, longitudinal in air, okay, in air, in solid and liquid also, but generally in air sound will travel, or in air or in gas sound will travel in longitudinal form. And longitudinal wave means, you know, there is the compression, rarefaction, compression, rarefaction, okay, like this, compression, rarefaction, like this structure. So that is compression, rarefaction, compression, by this way it will spread. Okay, in all three medium it will move through the longitudinal, but mostly it will use this longitudinal process, movement in air. And transverse means, you know, light wave generally move in the transverse wave. Light wave also, what is the difference between light and sound wave, that I will explain now. But before that, you learn what is transverse wave. Transverse waves, you know, there is a crest and trough, so two extreme, okay, that is amplitude, that is also amplitude, and that is a complete vibration. So generally sound will travel in the form of transverse wave, this wave, in solid and liquid surface. Okay, in liquid surface and in solid, sound will travel in the form of transverse wave, and in the gas or in the air, you know, that is in longitudinal form. Okay, so that is the thing students. I hope now you can understand what is sound. Sound is a energy particle, that is the range, audible range of the sound, and what the term related with the sound, amplitude, time period, and all other things. Okay, so students, now come to the difference between sound and light. Okay, so sound and what is the difference between, you know, sound will generally move mechanical, in the form of mechanical wave. Okay, and light is a electromagnetic wave. Electromagnetic means, students, electromagnetic means it doesn't need, it can move in vacuum. Okay, it can travel in vacuum, but sound can't travel in vacuum because it is a mechanical wave. It needs medium to travel. Okay, and sound is longitudinal in air, longitudinal in air, that is also one point. Okay, means means it will longitudinal means, suppose there is the these types of compression and rarefaction, means along the direction of the propagation of wave, sound will transfer along the direction of propagation of wave. Okay, and that's why it is called elastic, elastic in nature. Elastic means, you know, elastic means, suppose I will push this finger, that will again this finger again come back to this finger. So this elastic type behavior has sound have. Okay, but light is completely different, that is can travel in the transverse form, and it is a electromagnetic wave, that's why it can travel in vacuum, whereas sound can't travel in vacuum because sound needs a medium. Okay, which needs, sound can travel through the vibration, and vibration takes place if there is a medium or there is the particle. Okay, so students, I hope you can understand that is the basic difference. Okay, it is longitudinal in air and it is, you know, transverse. This difference is already written in your book, transverse in nature. Okay, and it's very fast. Okay, sound travel 3 into 10 to the power 8 meter per second, and in air, sound, you know, speed of sound is different in different medium. Okay, so in air, around 340 meter per second sound wave, and in water around 2240. Okay, you know that because water is liquid. Okay, so sound travel faster in denser medium, sounds travel faster that is also you learn, no problem. Okay, so now coming to the some relations. The some relation means, v is equal to f into lambda, that is a relation. Means v means wave velocity. So wave velocity means in 1 second distance travel in 1 second. Okay, means the wave will travel, the wave nature of the wave which will travel in 1 second, how many distance, that distance is called wave velocity. That is equal to frequency into wavelength. Okay, so that relation is very important. And another one relation also you need to learn, that is v is equal to root over gamma p by d. Means the speed v of a longitudinal wave in gaseous medium of density d. D is the density. Okay, that is the speed, or yes, speed of a longitudinal wave. Okay, speed of a longitudinal wave in gaseous medium. Okay, speed of longitudinal wave in gaseous medium is equal to, you can say that is a relation you need to remember, where gamma is the ratio of the specific heats, is equal to 1.4 in air, the value, and d is the density, p is the pressure. If the pressure of the medium is pre, okay, and density is d, then the speed of longitudinal wave in that medium will be v is equal to root over gamma p by d. That is some relations you need to just you need to once remember just. Okay student, that is the all basics about the sound. Next class I will teach about the echo.